I'm dealing with what's called the Working Well program, which is the program that we do provincially to try and help well owners understand their wells better. And we call the program Working Well, and some of you have been at some of the workshops, and so you'll have seen a lot of this before. I'm going to skim over some things. I've taken a lot of things from the presentation. I'm just going to try and get quickly through them and skim the top, and if you're interested in seeing more, sign up for one of our workshops. So kind of the background of the whole thing, the whole Working Well program kind of started back when we had the coal bed methane information sessions around the province in 2006. And at that point, there was identified a lot of information gaps between well owners and what the situation was out there about their wells. And there are 200,000 plus wells in the province, and about around 3,000 drilled new wells every year. So there's a lot of wells, there's a lot of new wells, there's a lot of old wells. The whole program was piloted in 2006. The current format that we do the workshops in, we started in 2008. And the whole program is driven by a steering committee that includes people from Environment and Parks, Agriculture and Forestry, Alberta Health Services, Alberta Water Well Drilling Association, and counties and municipal districts. And that's a steering committee that kind of helps guide us through the whole process. From 2008 to 2015, the official total to that point was 198 workshops. We had 60 municipalities and organizations host those workshops. We had about almost 5,500 participants, and we had 169 program delivery staff, people helping out, from everything from health inspectors to agriculture, environment staff, Ag Canada staff, you name it. There was a lot of people involved. At the workshops, we always do a workshop. You always get a participant survey at any kind of these things. So we've collected about 3,300 workshop participant surveys, and then those get collated into an annual report. And we also do a survey. We phone people back 6 months after. Anyone is invited to put their name and phone number down on that participant survey, and we phone them back in 6 months and do a longer-term follow-up work survey and get some kind of more long-term feedback on things. Typical workshop, we start with understanding groundwater, which is a video that talks about the water cycle and shows a lot of the things that the display model did here. We talk about how wells work and how they're constructed. We talk about common water well problems. We talk about the 10 most likely things to pollute or contaminate your well. We talk about shock chlorinating your well as a maintenance item. We talk about taking water samples and wrap up with some take-home messages. And that whole workshop usually runs 3.5 to 4 hours, depending on how many questions there are and who's doing the talking. I lead the workshops, and then we have people from agriculture and environment and health and the Drilling Association come and help with the presentation. So understanding groundwater, as I mentioned, basically a video, hidden water video that's available online as well. We do that to give a basic understanding of the beginning. Then we talk about how wells work, and we talk about the key components of the water well. Starting with, obviously, you need a hole, so the borehole. Talk about that. Next item will be the surface casing, which goes in the hole to keep the borehole open, house the pumping equipment, and help exclude undesirable aquifers. So drillers will quite often what they call case off an undesirable aquifer to go down into the water that they want. So John talked about those surficial aquifers. They're usually gravelly. They're always harder than heck and often have a lot of iron in them. People don't want that in their house, so they'll case it off with the surface casing and go down into deeper water down below. Really important part of the well is what we call the annular seal. Where the surface casing is, actually the borehole is usually about this much bigger than the surface casing. So if that's not sealed properly, surface water can sneak in along the top and run down here, or these shallow aquifers can come in and go along the side of the casing and down into the bottom end of the well and contaminate the water that you thought you were getting. So that annular seal seals that casing into the ground and prevents a mixing of aquifers, contamination from the surface, and there's a variety of different ways that drillers will do that. Down the bottom end of the well where the water's coming in, the intake portion, John mentioned that there's surficial aquifers, the sands and gravels. Where those are the case, they'll use typically a stainless steel screen to keep the sand out. The vast majority of our wells in central Alberta and the Red Deer River watershed area are bedrock wells that John talked about, permeable sandstones, fractured shales, fractured coals, and in those cases there's usually a plastic liner that's down the bottom end of the well with just slots cut in it, maybe a skill saw or electric drill or a cutting torch if it's an old steel liner, and that kind of thing. So that's where the water's coming in. Then the water's got to get out of the well, so we talk about pumps a little bit and pitless adapters, which make that sanitary frost-free connection down about 8 feet below the ground, so the water can come from the pump through the side of the casing and off to where you're using it without freezing. And a well cap, obviously you don't want kids dropping things down the well and that kind of thing, so well caps are really, really important. So we talk about the typical bedrock aquifers, which I mentioned earlier. It's not uncommon, especially when you get west from here, to have what we call open hole completion, where there's a bit of surface casing and then a bare naked borehole down in the sandstone. Not very often done anymore, but there are some still around. Surface casing, these wells, this type of well has a surface casing that goes down to wherever the surface casing goes to, hopefully to make it, to eliminate all but one aquifer, but not always. And then a liner down here, and there's a single string construction where there's one size of casing all the way down and an annular seal above whatever point they've sealed that at. Surficial aquifers, I mentioned, they were going down into a sandstone, or sorry, into a sand or sand and gravel, stainless steel screen down there. In the northeast part of the province, there's a lot of these old called bored wells that are larger diameter. They're put in areas where the water is quite low yielding and fairly shallow, and the main idea here is you've got a big reservoir of water underground. So if you've got a 2-foot cribbing with water in it, you've got about almost 20 gallons in every foot of depth of storage down there, and that's gives them usable water where there may not be otherwise. We talk about well drilling reports. Every well is supposed to have a well drilling report, and so we explain to people what's on them, and we kind of really quickly go through that. Then once we quickly explain that, we do a little exercise, a do-it-yourself part of the program. We call it a workshop for a reason, because we put people to work a little bit. We print off well reports for everyone that's coming. We get their land location when they sign up. We print off their well report, and most of the time we can find them, but sometimes we can't, because wells didn't have to be reported until about the early 70s. So there's lots of old water wells around that have no well reports. So we give them a template, and we give them their well report, and I highlight the pertinent information on the well report. So I highlight the borehole information, for example, in orange. Then I highlight the surface casing information in green, the annular seal information in purple, the intake portion is in pink, and blue. There's the slots in the screen showing up there. And we'll go to the second page and draw the static water level in the well where the water sits at when it's not being used. And was mentioned about artesian conditions. Most of the wells that I deal with in the province are slightly artesian. They're not flowing artesian, but they are artesian in that you hit the water at, say, 150 feet, the water level comes up to 50 feet from the surface, for example, due to those artesian pressures. And the drilling report's supposed to recommend a pumping rate and a pump depth, so that's highlighted. We get them to draw that in if it's there. And if they have a little bit of time, we get them to draw the lithology along the side so they can see where their aquifer is. So in this example, here's a slotted liner here, and it's down beside a sandstone, and that was the aquifer. And the annular seal information, you can see where the surface casing was sealed into a fairly tight material, which would be, in our example here, a shale. And then we do a similar thing with the surficial wells with the same idea with screens and slots and that kind of thing. Yeah?
So I was just wondering, does that drilling report transfer, like if I were to buy a property where there was a well? does that transfer in the sale of the home to the new owner?
The drilling reports are filed at Alberta Environment, so you can go on the internet and at the end, I think I've got a slide here that you can go on there and put in land location. It'll bring up all the water wells on that land location, and you can search by land location, by owner's name, original owner's name, like the original owner of the well, but usually the land location is what people search by. So they are filed, but if it's an old well, it may not be there. If the driller wasn't very good at paperwork, sometimes it's not there. Sometimes the computer input is wrong and it puts something west of the 4th meridian instead of west of the 5th, and sometimes they get lost that way. But for the most part, hopefully they're there. We talk about well problems, mainly things that cause reduction in yield, changes in water quality, sediment coming into the water, and the main problems of those typically are biofouling and what we call overpumping. And biofouling is caused by nuisance bacteria that grow in the groundwater in the wells. They'll tend to clog up the slots where the water's coming into the well. They'll clog up the pump. They'll clog up some of the material, the aquifer materials, and reduce the yield. Create some problems. The two major ones would be what we call iron-related bacteria that, for the lack of a better explanation, feed on iron. They create a red slime. Sulfate-reducing bacteria are a similar type of bacteria that are anaerobic. They make the water, give the hydrogen sulfide odor and give you black slime problems. And there's other ones as well, but those are the two big ones that we talk about. And just the act of drilling a well and pumping it aggravates these things from happening. We used to think they were a contamination problem, but now the information is, hey, these things a lot of the times were naturally present in the aquifer, but the fact that you've developed a well there makes a happy place for them to live, and you'll aggravate the problem. We have the major symptoms. Typically, people can look in their septic or their toilet tank and they'll see red slime or black slime, usually red slime like that toilet tank shows, and kind of the major indication of the things you see on the surface. If the driller comes and services your well and pulls the pump, you'll often see red or black slime or both on the drop pipe to the pump and on the pump itself. So you get a decrease in yield. We have some downhole footage that we show for the downhole well camera showing what some of this stuff looks like right down in the well. So normally wives aren't allowed to look at those, just the husbands are, because wives are a little more sensitive to that kind of thing, but some of these are pretty ugly. So we talk about what the whole format of the workshop is, what the problem is and what you can do about it. And so what we're talking as the only tool a homeowner typically has is regular disinfection or shock chlorination of the well. And usually that's got to be started early in the life of the well, because as that slime layer gets thicker and thicker, it creates more and more of a problem, and it's harder and harder to remove. And at some point, you may be better off to have a driller come in and professionally clean the well before you're going to have much luck with the shock chlorination. So it's a maintenance thing. The other thing that keeps coming up in the workshops is overpumping. That's pumping the well harder than it really should be pumped. And that's one of the things. Our aquifers are fairly limited here. It isn't uncommon in this area to maybe have a well that's only good for 1 gallon or 2 gallons a minute. That's just the way it is. That's all you've got. And by pumping that well too hard, you create all kinds of different problems with aerating the water to aggravate those biofouling bacteria, having water washing down the side of the borehole and removing some of the sediment, or just moving the water so fast. The faster you move water, the more sediment's going to move, and the same thing potentially can happen in your well. We usually do the top 10 well enemies, but I just put 2 in here for today. Number 1 on our hit list is old, abandoned, and unused water wells. There are thousands of them around the province. We saw in the little well model here, when you put a contaminant on that sandy surface, it travels through. The fastest way to put it in there was like she did with the contaminant. She put it in the well, and it went choom right down to the bottom of the well, and then went across and contaminated something else. So these old wells are a problem, and most of them have old steel casing. Steel casing doesn't last forever. It gets corrosion holes in it and that kind of thing, and you can get an old well corroding casing holes in the casing, an undesirable or contaminated aquifer here, it's going to run down the well and it's going to create a contamination plume, which when you pump the new well, it's going to create a problem in the new well. So that's one of the things on our hit list. We encourage people to plug and decommission those wells, and ideally we like to see it done by a well driller, so it's done, hopefully done properly, but we have fact sheets in the binder that talk about plugging wells and that kind of thing, and so that's one of the issues that we try and deal with. Number two is well pits, and these aren't even legal anymore. They haven't been legal since 1993 to put these in, but they're really common in the old wells. And that's where people would dig out a pit around where their well is to house their pumping equipment down below ground without having it freeze. But it seemed like a good idea at the time, but it isn't such a good idea because it becomes a funnel for contamination, surface contamination, shallow groundwater seepage contamination, and just all kinds of different things happen. And they're not, we talked about coal bed methane a little bit earlier, it was discussed. There's a water well that was up near Camrose. A lot of their aquifers are fractured coal formations. That's the only water they have. It just happens to have gas in it as well because it's in a coal formation, and enough came out of that well one day to blow up the house. So that's another issue around well pits and around wells actually in basements as well. Plus the possibility of the well, if you're in a well pit, if there's a confined space down there, if there happens to be air coming out of the well, which sometimes happens under some kinds of well construction, people can suffocate and die down in these things, so they are dangerous from that aspect as well. So what you can do, obviously getting rid of them, temporarily dealing with them, they may be able to put a sanitary well seal on them, that kind of thing, but it's just one of the two high-risk situations we have with wells. You asked about shock chlorination. We talk about how people would do that, and there's a fact sheet in our binder. The binder we hand out to everybody at the workshop looks like this. It's got all the slides from the presentation. It's got a whole series of fact sheets in it. This is the one on shock chlorination, but they're all in the binder as a resource for people to take home. And basically we talk about when you shock chlorinate, and the drillers always chlorinate after they're done with a new well. Contamination, water problems, lab tests coming back with high bacteria, slime in the toilet tank, all that kind of stuff is when you might shock chlorinate. Nothing is without risk, so we try and warn people, hey, there's some potential problems here. We say the key one is more chlorine is not better. The stronger the chlorine solution, the less effective it often is, and the more corrosive it is. And if you've got an old well that's got a steel casing that's already 3/4 rusted out, and you put more chlorine and pump it and do all kinds of things with it, you may create some other problems that were going to happen anyway. You just speeded them up a little bit by the chlorination process. And once again, often it's not a bad idea to have a licensed well driller deal with some of those older wells. We recommend on the chlorination they stay below 200 part per million chlorine solution, making that solution with either household bleach, industrial bleach, which is just 12% instead of 5 1/4. That stuff has a limited shelf life. It deteriorates in storage, so we tell people don't buy a bunch and save it for next time. And they can also mix a solution up with granular or pelletized chlorine. And the key thing there is to make it into a solution. You don't dump this dry stuff down the well because it can cement the pump into the well. It can corrode the pitless adapter, corrode the casing, and cause all kinds of problems there. We recommend what's called the bulk displacement method, where we calculate twice the volume of water that's in the well bore, mix the chlorine in it to make a 200 part per million solution, run that down the well, gives enough extra water to hydraulically push some of that chlorine out into the formation around the well. So that whole calculation process it's one of the fact sheet in the binder. We kind of go through that with people, figuring out how much water's in the well, how much water they're going to need to make that 2 times the volume, and calc that out. And these calculations are all in the fact sheet. And then we figure out how much chlorine they're going to need and work that out, and talk about putting it down the well, flushing it through the whole system, letting it sit, and at the end of the day, you let the whole system pump the system out and clear the chlorine out of the well, and flush everything all out. We also mentioned pH adjusted chlorination. Chlorine is, the higher the pH of the water in chlorine solution, the lower the effectiveness of the chlorine for killing bacteria. And so as the pH typically around here for a lot of our groundwater is around 8. So at 8, chlorine's only got about 12% of its biocidal effect compared to 100% at 5.5. And so when you add chlorine to it, you actually raise the pH higher than that. So you can potentially raise the pH easily up to 10, which has got a biocidal effect of less than 1% of what it had originally. So sometimes people are, the drillers are setting up to add some acids to the water and that kind of thing to adjust the pH to get a better chlorine, better kill. Talk about taking water samples. You have a health inspector come and talk about that. When to sample, how often, how to get the sample to the lab, and that kind of thing. The health centers take the samples, but they do not take agricultural water samples. They only take samples for human consumption. They don't take mortgage transaction samples. They don't do samples looking for dissolved gases. They don't do samples for the effectiveness of water treatment equipment, and they don't do samples when the paperwork is not done right. The labs are accredited. They get thousands of water samples a year. It's a waste of time for them to put out information that's got some inaccuracies with it right from the beginning. And other people will, people are looking for those sort of things. They go on to fee for service. John had mentioned heavy metals and that kind of thing. They're not normally part of these samples. If you want a trace metal analysis done in your water, you have to convince the health inspector that you have a reason to look for that, and then he's got to call the lab and make an arrangement, and then he actually often has to go out and take the sample because a lot of those samples are acidized with nitric acid to stabilize things. So they have to take the sample and take it back in. So it's significantly more time and effort and cost for that. And some of the arsenic, they've got some special arrangements for the arsenic situation where people are checking the arsenic levels around the province. But so I haven't talked to anybody right around here that's doing that yet, but some of the health offices are. Bacteria samples, key thing on those, the health offices take those samples, but the big important thing is the sample has to reach the lab within 24 hours of the time it's taken. So it's really critical. Every health office has a window of opportunity to drop samples off so it can be picked up by the courier and taken to the lab and hit the lab to be tested within 24 hours, or else the lab throws it away and you get a phone call, you've got to take another sample. I've talked to people who have taken 3 and 4 samples before they finally got one in because things went wrong from one reason or another. The paperwork I mentioned is really, really important. Something as simple as somebody not circling AM and PM on their form gets the sample thrown away, and they've got to go take another sample and take it into town and do that. It's not such a big deal on the close Highway 2 corridor here, but if you live at Hinton and you're sampling, you live 20 miles out of town, it's really a pain in the butt to get all this stuff, all the ducks to line up. Basically, they're looking for presence and absence of coliforms and E. coli in those bacteria tests. They're not looking for those slime-forming bacteria that I mentioned earlier. That's not part of the test at all. It's just coliforms and E. coli. Chemical analysis tests, similar sort of thing, except they're not time sensitive. It's really important that the paperwork be done right and then the sample makes it to the lab. The result of the day, they'll get results. The 16 different parameters, the basic things, pH, sodium, chlorides, fluorides, that kind of thing. And if there's anything specific they need to look for, they have to talk to the health inspector about that. We wrap up with take-home messages. It's really important we tell people to keep good records about their well and monitor water levels whenever they get a chance. And you've got to keep those records yourself and file them and be able to pass them on to the next owner, or you can have them for your own use. If you get in a dispute with somebody, and oil and gas situation always comes as a good whipping boy on this one, but if you think something has happened and you don't have any evidence to back up what you had before, really you don't have much of a leg to stand on when it comes to an argument between you and somebody else. We talk about chalk chlorinating on a regular basis as a maintenance practice to keep the bacteria from getting too slimy and too thick and be too much of a problem. Talk about testing water on a regular basis, bacteria test, chemical analysis, and health offices have those. And we also talk about eliminating old wells and getting rid of well pits whenever you possibly can. Fact sheets in the binder, as I mentioned. Evaluation forms I mentioned already. We phone people back 6-8 months after the workshop and do that. As far as what's been achieved, from some of the surveys, 98% of the participants strongly agreed that the workshop increased their understanding of how their wells work. 98% of participants agreed the workshop provided information that was helpful in maintaining and managing their wells. 79% said they would test their well water. This is a commitment to act. 74% said they would keep records of test results and maintenance, so people are going to hopefully file that stuff. And 63 said they would regularly inspect their well and the area around their well to make sure there's not water ponding around it, or the lid, the cap is secure and that kind of thing. So